Hello out there. Today our topic is acids and bases and the pH scale. And I know we've all heard of acids. We throw that word around all the time. You've heard of battery acid and stomach acid and maybe hydrochloric acid. You probably know there's acid in a Coke. There's acid in lemons and oranges. You've heard of citric acid. And then on the flip side, we've got bases. And there's bases, maybe you don't hear about those quite as much, but like all the cleaning supplies and toothpaste. I got toothpaste and bleach. I just pulled this stuff out from under the sink. Ammonia, soaps, a lot of soaps, that kind of thing. They're all bases. And so acids and bases are in our lives, and they're oftentimes really helpful. But sometimes they can be harmful too, especially environmentally. And so that's what today's all about. Some of you already have notes like this. If you do, just add to them. If you don't, we can just start from scratch. So our essential questions are these. What's an acid? What's a base? And the pH scale, which we've heard of. How does that work? And so I'm just going to go ahead and define the acid and base for you. Now that we know what ions are from past instruction, this makes more sense. An acid is anything that when you put it in water, it releases hydrogen ions. And so just notice our hydrogen ions have a plus charge, they're cations. And then a base is anything that releases what's called a hydroxide ion, polyatomic anion, to make it sound fancy, with a negative charge. So anything that you put in water, like soap, and it releases hydroxide ions, that's a base. And so how do we measure these, the strength of acids and bases? Well, we use this thing called the pH scale, and it's pretty cool, and I'm going to guess a lot of you know of it. It's, in the most simple sense, it's a scale that goes from 0 to 14. 0 is our strong acid, 14 is a strong base, and 7 is neutral, right in the middle, right neutral there by 7. And so a 6 is a lot weaker of an acid than a 0 or a 1. Okay, and so check it out. You guys know what a seesaw is, like that playground equipment at the park that kids go back and forth on. If we have a situation where we have more hydrogen ions than hydroxide ions in a solution, in a liquid, it's an acid. And we know the number on the pH scale is less than 7. If we have a situation where we have more hydroxide ions than hydrogen, it's a base. And we know the pH value is more than 7. And so maybe you've heard that if you spill an acid, how do you clean it up? With a base. If you spill a base, you clean it up with an acid. And so let's just take a look at how that works. If you have the same number of hydrogen ions and the same number of hydroxide ions, your solution is neutral. And what that means is the pH value is 7. But why? If we just had one hydrogen and one hydroxide, look at what they make. Hydrogen and OH make H2O, water. And so if you had a billion hydrogens and a billion hydroxides, you have a billion water molecules. And so whatever the concentration is, if it's the same, it's neutral. Okay? So we're going to talk about the pH scale just a little bit more. And I want you to write this in on your notes. And so on one sense, it looks like it's just a 1, 2, 3, 4, 5, 6, 7, and so forth. But write this down. The pH scale is logarithmic. And what that means is that every step on it is an exponential step. And it's just like a Richter scale for measuring earthquakes. If we have an earthquake and it's Richter scale 4, we just sleep right through it. But if it's a 6, which is only 2 more than a 4, it doesn't seem like that much. If it's a 6, the buildings start to shake and maybe collapse and windows are breaking, and it's a lot more damaging. Why? Because they're exponential steps. And so on the pH scale, every step is the power of 10. And so you can see that here with the visual. pH 6, we're looking at the concentration of ions. pH 5, has got 100, pH 6 has got 10, pH 4 has got 1,000. These are measurements of how many ions there are. But just simply, if we look at a pH 6 compared to pH 5, that's a power of 10. What that means is pH 5 is 10 times more acidic than a 6. A 4 is 10 times more than a 5, but if you compare a 4 to a 6, it's 10 times 10. And so now it's 100 times more acidic than a 6. And so a 3 would be 1,000 times more. And it goes the same way with the bases too. So a pH 13 compared to a 10, we got 1, 2, 3, so it'd be like 10 times 10 times 10. It's 1,000 times difference. And so you can get really big changes. And so that's really important to know. I've got a demo to show you what that looks like. Here I've got, and I made colored water. I've got pH, we're going to say this is pH 0. And if I wanted to make this a pH 1, which is 10 times weaker than a pH 0, what I would do is I'd put in 10 milliliters of that. And then I'm going to dilute it with water all the way up to 100. So I put in 9 parts water, 1 part acid. And you can see just with the colors that now this is 10 times less color than this. But now so that's a pH 0, pH 1. If I wanted a pH 2, here's what I'd do. I'd take 10 milliliters of this and do the same process. It's called serial dilution. And then I'm going to add 9 parts of water. And so already pH 0, pH 1, pH 2, and as you go up, it gets 10 times weaker or stronger, depending on which direction you're going, as you go from pH, every step on the pH scale. Works the same way with the base scale going backwards, and I won't do it, but if this was our pH 14, I'd make a pH 13 by taking 10 milliliters of that, 90 of water, and then right on down the line. And so that's what the pH scale is all about. Hopefully that gives you an appreciation for it. Just to wrap up here, we've got how do we measure these things? And so we've done a lab that involved bromothiamyl blue. Remember we were blowing bubbles into the bromothiamyl blue, making carbonic acid, and the bromothiamyl blue changed colors. It's called an indicator. It's like a chemical detective, and it changes colors when it's in the presence of an acid or a base. And so there's all different kinds. This is a kind called litmus paper. You just basically dip this paper into the liquid and it turns colors if it's in the presence of an acid or base. Here's the easiest one to work with, which is pH paper. And I basically take this little piece of paper, here I'll do it, and I'll dip it in water and it turns colors a little bit. And then you line up the color with your color scale, and I'll just do this one here. It looks like this water that is in that beaker is a pH 6, so it's a slight acid. And then there are pH probes too, where you just dip this into the liquid like this, and it gives you a reading. And so you got some more sophisticated equipment too. But there's different types of equipment have their purpose, and so. Here's the assignment that's going to happen with this, and I wish we were in the lab, you guys, because there's all kinds of kind of really fun things and color changes and bubbles and fizzy things you can do with acids and bases. We're not going to be able to do that this time, but I'm going to give you a online lab to do, and it looks like this. Right now we're testing ammonia, which spoiler alert, we know it's a base, and what it's going to do, I'm going to have pH paper here. And I grab it and I put it in there, and I already did this one, and it came out that color. And if I line it up here, I know that ammonia is a pH 11, right? And so there's going to be a lab an assignment that comes with this that'll hopefully help you explore and recognize how many acids and bases that you have in your house. Okay. I hope that was helpful for you. Please take a moment, write a summary, answer those questions in your own words, add some questions in on the side here. And thanks for joining me, you guys. Make sure you fill out the Google form too, so I know you watched the video. Okay, take care.